All right, we have next speaker here, but before we start, I would like to just repeat some announcements. Don't forget to rate the sessions on shed.com. And when you're entering or leaving the room during the talk, just please don't make a lot of noise and try to hold the doors. When you're asking questions, ask them loudly so the speaker can hear you. And don't forget to join the closing session on Sunday where you can win great prizes. And here we have Davide Cavalca, who will be talking about running CentOS on Facebook fleet. So, floor is yours.
All right. Is this on? Yeah. Hello, everybody. My name is Davide. I'm a production engineer at Facebook. And as I said, we'll be talking about how we run CentOS on our fleet. Before we start, quick agenda for today. I'll begin with a quick primer of our infrastructure and what role the operating system plays. We'll then deep dive in what we do to manage a few parts of the operating system at Facebook. We'll talk about packaging. We'll talk about operating system updates. We'll talk about configuration management using Chef. Then we'll discuss provisioning, how we get machines in production. And finally, I'll close with a few words about containers. So, infrastructure. We have hundreds of thousands of physical machines distributed across several data centers all over the world. And as I said, these are all physical machines. These are not VMs. All of these machines have to run an operating system, which is CentOS. And I'm on the operating systems team. We take care of maintaining and managing the OS on the fleet and provide a platform for other service owners. There are various services at Facebook that run on bare metal directly. So think about stuff like databases, for example, MySQL or Hadoop. And there's also services that run on other platforms built on top of the base infrastructure. For example, services that run in container on top of our container platform. And my team is responsible for the bare metal experience of the fleet, for the OS itself, for tooling that is around the OS. So things, as I said before, like packaging and config management. Now, it's worth pointing out, my team is a small team. We don't manage every single machine in the fleet. In fact, no team at Facebook manages every single machine in the fleet. The approach is that individual service owners, like the people that work on the databases, the people that work on web servers, are responsible for their own machines. We provide tooling and we provide support. But then it's up to every team to make sure things like, okay, that your operating system is up to date and that Chef is running correctly on your machines and stuff like that. And this is important because this is one of the things that make it possible for us for this to scale. So the approach we take within the operating system is to try to leverage as much as possible what work the community is doing. This is actually a slide I used internally to explain this within Facebook. And the idea is that especially in the operating system space, what sets the direction is the community. We're not in the business of making our own distro. We want to be able to use as much as possible what the community builds because the community are the experts here. And at the same time, while we do want to move fast, often the community itself moves even faster and builds new features and new tooling that we can leverage. And this is tool we don't have to write ourselves. We don't have to maintain. People always like to write new things because you can have new shiny things that you can claim as your own. But if you can leverage things that other people build and make them better, that's an improvement for you and it's an improvement for the community itself. And again, if we can build new things, we try to share them as much as possible. And I'll point out throughout the talk things that we made that are open source and things that we made that aren't, in case you're interested. I did a talk last year here at DevConf with Phil, my coworker, where we talked extensively about our philosophy here. And you can see the link there. I'll publish the slide later, so don't worry about seeing the link. So all right, I said we're on CentOS. I've been at Facebook for about 6 years. When I joined, we were running CentOS 5. Now we're running CentOS 7. Before CentOS, I think we were running Fedora Core 4. Before that, I think we were running whatever Zach was running in his dorm room. The thing we need from the operating system is, for once, we need something that is stable. I'll talk later about how we approach updating the OS, but as you might imagine, updating the OS is an expensive process. So we need stability throughout the life cycle of the OS, and we need binary compatibility between minor releases, because Grant asks people to recompile everything whenever there's like a minor security update. And then, yes, we need security updates. There's a lot of packages in the distro. Well, for some specific packages, we will maintain them internally and follow them closely. For a lot of things, we don't, and we don't have the ability, we don't have the manpower, we don't have the interest, quite frankly. And in a lot of cases, I don't necessarily want to follow closely security updates for a random package that a developer installed on their development machine to, I don't know, parse JSON or whatever. It's a lot easier if I get these automatically from the distro. And the other thing that CentOS brings us is tooling that is mature and is well understood. So products like RPM and YAML that are well understood within the community, and things like Appel that gives us more up-to-date packages coming from Fedora. And to this point, the relationship with Fedora means that when we do need packages that are more up-to-date from the ones included in the distro, we can just pull them from there and backport them easily in production. So the way we do that is with a thing that we nicknamed internally FTL, a fast thin layer. And the idea is that we run CentOS, and then for things that we care about, for things that we need to track closely from, like say we need to track the latest Git master or whatever, we just backport the packages from Fedora. And this is, for the things that my team cares about, this is mostly like plumbing and low-level packages. And I'll have a few examples later, but think like stuff like util Linux, for example. You don't necessarily need the latest util Linux, but developers like having access to the latest tools. So we try to do that whenever we can. We publish these RPMs, these backports on GitHub. We don't publish all of them, mostly because of time, but we try to publish as much as possible. They're on that GitHub repo. These are set up in such a way that they should build as they are on CentOS plus Apple. Some of them have some Facebook-specific stuff in them, but it's all gated by a %Facebook macro. So if you build them yourself, you won't get our like crazy NTP servers or whatever. So what this gives us is a stable distribution with the ability and the opportunity for us to track changes more quickly and move faster. So let's see a couple of examples. One example I like about this is systemd. So we started looking at systemd at Facebook when we started moving to CentOS 7, because of course CentOS 7 was shipping with systemd. CentOS 7 ships with systemd 2.19. And when we started looking at systemd in depth, we realized there was a lot of features that we were interested in leveraging within systemd that were not in 2.19. And we didn't really want to be in the business of backporting stuff from master into 2.19, because then it would have been problematic to also work with Upstream. So we decided, okay, we're just going to run master. And conveniently enough, Rawhide packages the latest systemd release. So we just backported that. And that's on GitHub in that repo I mentioned before. While we did this, we discovered that systemd changed something in their shared libraries, so that the libraries packages in CentOS are linked against libraries that are no longer available in the latest master. So to work around this, we built a package called systemd compat-libs, which is just a small .so that provides all the symbols that are needed. So you don't need to rebuild stuff like Apache that happens to depend on this. That's also on GitHub. The actual code is there, but the actual code is like a Mason file and a 10-line header. The packaging is also in RPM backports. And this gives us the ability to play with a lot of new features. We did a lot of work internally with CGRUB2, and we actually contributed upstream, both in the kernel and in systemd, the support for CGRUB2. And this gives us the opportunity to test this out, make changes, get them shipped upstream, quickly backport them in our build, and then when a new stable came along, we could roll that in production. We can play with new features, things like dynamic users that might be interesting to try out early on. So then we can go to service owners internally at Facebook and tell them, okay, look, there's this feature you can use that you might not know about. Also on systemd, we have a couple of Chef cookbooks. And I'll talk about Chef later, but I just want to mention we have one cookbook to manage systemd itself on a machine and its services. And we have a cookbook to manage systemd timers in case you want to use them as a cron replacement. These are also on GitHub. I talked extensively about what we do with systemd at Facebook at All Systems Go this year and at systemd-conf the year before. That's the link to my last talk that has a link to the earlier talk if you're interested in hearing more about these. Another example I want to bring up is init scripts. So initscripts, if you're not aware of, is the package that's in CentOS and also in Fedora that contains all of the stuff that goes under etc init.d, like things like etc init.d netconsole, for example. It also ships network scripts, etc init.d networking start, for example, and etc sysconfig network scripts. We care about network scripts because that's how we manage the network at Facebook. We don't use Network Manager and we don't use networkd. We have a lot of logic built around network scripts that we'd like to keep working. And so we had a bunch of fixes to network scripts that we accumulated over the years and never really managed to upstream. But then by going to conferences, we got in touch with the maintainers. We worked with them. They set up a GitHub repo. We were able to contribute our PRs. We actually became co-maintainers of the repo. That's the repo, and everything is upstream now. But we were able to contribute a lot of fixes to IPv6 support. The network in Facebook is for the vast majority v6 only. We were able to contribute support for per-device routes. Recently, just last month, I added support for not shutting down interfaces when you shut down the machine, which it turns out, in our case, was causing issues. And again, this is something that we have. It's all upstream, and we can deploy in production quickly by just getting the changes we need. In this case, we don't backport from override. In this case, we just take the CentOS version and we backport just network scripts because that was easier for us to roll out. And for something like initscripts, we wanted to minimize the potential fallout of making a mistake in the backport. Something else that is relevant to this is the kernel. So as you know, CentOS and RHEL ship with their own kernel, which tends to be a somewhat older version of the kernel with a lot of features backported in. We have a different approach to this where we just run the upstream kernel, or as close as possible to the upstream kernel. Our kernel team does all of the development in master with Linus 3. When the changes they're working on land in master, they backport them to internal branches. Usually we have 2 ongoing branches within the company, one for like stable version and one for development. And then we have some infrastructure for doing automated testing and canarying, and we have infrastructure for automating rollouts. Because as you might imagine, rolling out kernels on a wide variety of machines involves, well, installing the kernel, but then you have to reboot the boxes. And for some services, coordinating reboots is easy. For others, it's less easy. And you also need to be able to track things like performance regressions and stuff like that. My coworker Yannick did a talk about this at Scale 15x that you should watch if you're interested in kernel. All right, now let's deep dive into packaging. And I started with packaging because packaging is fairly core to how you would manage the operating system. Now, the approach we take for packaging is that we try to leverage, again, as much as possible from upstream. So we have a public mirror of CentOS at mirror.facebook.net/CentOS. You can use it if you want. It's synced automatically. It should have HTTPS as well, but I need to check that. We take the upstream repos straight from CentOS. So repos like OS extras, whatever, those we just import directly, repo and metadata in our infrastructure. We then have 2 internal repos, one called site packages and one fb-runtime. Site packages is for RPMs we build internally against the system runtime, the same way you would build an RPM in CentOS to ship it with CentOS. fb-runtime is for packages we build internally, but they're built with our compiler against our glibc with our Facebook-specific stuff. The reason we have a separate thing is because we have a team that maintains compilers and libraries and stuff for production, and they like having control on these, and they like being able to follow their own schedules. So there's one repo dedicated for this, and there's one repo for system software. And then there's extra random one-off repos that are not normally enabled on machines unless they really need them for stuff like, oh, I really need to install this proprietary software that happens to ship its own version of OpenSSL, because why wouldn't it? And that goes into its own repo, so we don't end up with crazy libraries on every machine in the fleet. The way this actually works is that, so we have a large infrastructure. We have several geographical regions. Every region has a machine called a package master, which is where all these packages are served from. The packages themselves are stored in Subversion because we like having versioning. Subversion is also convenient for us because it gives us an easy way to do partial checkouts. So when you're doing testing, it's very easy to get stuff out. We are actually working on our implementation of this infrastructure using GlusterFS, but that's still in development. These packages are served from the package masters using just straight Apache 2 with nothing special. However, we don't point every machine to the package masters because that wouldn't work so well. So in every cluster, like local grouping of machines, We have varnish caches. And again, this is just straight upstream varnish with no special features or anything that caches the packages down. So this way we can lighten the load. The downside of doing this is that package propagation can take a bit. And if you need to do surgery on the repos, like delete packages, you have to take care and purge all the caches. But that's not terrible. It's not a big deal. There's a pretty picture for the flow that I stole from the internal wiki. So this is for how we serve packages. Now, the other side of the coin is how you build packages. And if you ever try building RPMs by hand, it requires a lot of specialized knowledge that if you're a systems engineer or if you're a packager, you're familiar with. But if you're an engineer that like works on, I don't know, Node.js or PHP, you don't necessarily want to learn how to write spec files. So we try to provide tools to make life easier for people that need to build packages, both for our team and for other engineers within Facebook. These two tools are called Yami and Packman. I'll start with Yami. Yami is a small wrapper that we wrote around mock that has source control integration. Mock, if you're not familiar with, is a tool that can build RPMs within a self-contained shroud. What Yami does is very simple. We have spec files and patches in source control in one of our internal repos. We have binary blobs in NFS, which is backed by Gluster in this case. And Yami takes these things together, sets up mock, feeds them to mock, builds the package, and gives you the logs back. So it gives you infrastructure for doing this in a way that is repeatable. It also gives you infrastructure for doing things like pull this package from rawhide and try to build it. And when you do that, as long as you're somewhat careful about what you're doing, you don't necessarily need to know every nuts and bolt of what the spec file is doing. And if you need to make changes, you can make them easily and track them. We also have automation for syncing spec files to GitHub in that repo that I mentioned before, rpm backport on GitHub. So for packages that could be interesting for people that are not us, we try to get them out as much as possible. So this is, as I said, is for system packages. So packages that are built as part of the distribution. This is what we use to build things like systemd and init scripts and every other package, or util Linux, any other package we need to backport or to build against the system. The other side of the coin is if you need to build Facebook runtime packages. So, and this tends to be internal software, like, I don't know, a piece of backend software that runs and does something, for example. And the customers of these are generally engineers that don't necessarily care much about packaging or RPM at all. They just want to build their software, get it shipped to production, and move on with their life. What we give them here is a small tool called Packman, which is just a wrapper around rpmbuild. And this builds the software using our build system, which is called Buck, is open source, but it just runs a command, essentially. It ties again in source control. It takes a small YAML config file that tells it what to build, how to call it, how to version it, and then builds it, makes a minimal spec file, packages it up, gives you an RPM, and then gives you the ability to publish it easily. So this makes it possible for engineers that don't necessarily want or care about RPM to package their software and deploy it easily. Yami and Packman are not open source primarily because they depend on a bunch of libraries that are also not open source. We would like to get them out at some point, but right now they're not. However, they're fairly straightforward tools, so if you happen to need something like that and wanted to write it, I'm sure you could probably do it fairly quickly. Now, what do we do on the clients? Well, the clients, of course, run RPM and YAM, as you might expect. We run RPM from rawhide. We run RPM from rawhide because we've been working with the RPM team for a while on a number of improvements to RPM itself that we wanted to leverage, and I'll talk about a few of these later. And in general, because this way we can also provide feedback on what is working well and what isn't. We run YAM from CentOS primarily, although we have a few PRs in YAM utils that we backport. I think the main thing we have here that we backported is a change to package cleanup so that it can roll both forwards and backwards when there's issues with RPM transactions. We also have DNF installed on every machine in the fleet because we want to start testing DNF. We haven't got a chance yet to get good measurements around DNF, but we've already validated that it mostly works for what we need. And this is one of the things we're going to focus on this year. We get DNF from that copper, which is just an upstream copper, and it works fine. We have cookbooks in Chef called fb-rpm and fb-yum. One is for installing RPM, as you might guess, and the other is for both installing YAM, but also managing things like what repos should a machine have, how should updates be managed. These are not open source yet, but hopefully we will get them out soon enough. Now, this works fine. For the most part, we are pretty happy with how RPM and YAML work on our fleet. However, throughout the years, we found out about a lot of things that are not necessarily an issue when you're running 10, 100 machines or something like that, but it can be an issue when you start running hundreds of thousands of machines. Generally speaking, when you have a lot of machines, one thing that you find out is that if something can go wrong, it will go wrong. Because even issues that happen on like 0.01% end up affecting a lot of machines. So here's a small compendium of things we found and how we dealt with them. So the first thing is an issue that came up fairly recently, actually, last year. If you do big RPM transactions, like we have a few RPMs that are a few gigabytes in size of our internal software. This can take a while to install. And when you install stuff, you end up filling up the I/O queue. If you do this on a database machine, you end up using all the I/O for RPM the database stalls. The database people don't like this when it happens, understandably. And then they blame Chef and my team. So what we decided to do for dealing with this was making a change to RPM and making call fsync every time it closes. And we started discussing this with Upstream. We filed a PR. There was a bunch of back and forth on whether that was the best approach, whether we could use different approaches. In the end, not this specific thing, but a feature that behaved essentially the same way was merged in RPM. It's behind a flag. The reason it's behind a flag is because you don't really want this all the time. You want this for specific workloads, for machines that have an SSD, because if you do this on a machine that doesn't have an SSD, your life will not be great. But that helped us a lot. And it made the database people happier, and it made these workloads work better. It improved a lot the reliability of Chef runs on our machines, because if RPM starts crashing and then maybe times out or fails, that's the problem. Now, speaking of RPM, when it times out or fails, the other things we see fairly frequently is corruption issues with the database. RPM uses BerkeleyDB for the database. BerkeleyDB has some interesting properties, like the fact that there's a lot of locking happening into it. One thing we found out fairly soon is that no matter what we did, we had like a baseline of corruption on the fleet. And corruption manifests with you try to install an RPM and you get spew, or it doesn't work, or it claims it's installed but it's not. So to fix this, we wrote a tool that looks at the RPM database and tries to deal with it. And I'll talk about that in a minute. Another thing we found is that if you kill -9 RPM in the middle of a transaction, you end up sometimes with empty files, sometimes with some files but not others. You might assume that makes sense, like you shouldn't kill -9 RPM. And killing -9 RPM doesn't happen that often. What does happen often, though, is people pulling the plug on a machine because they're servicing it, or automation or hard rebooting a machine in the middle of something. We don't have a good fix for these. If you end up with 0-byte files and half installed RPM, it's bad. What we do in that case is we just reimage the box, because it's not really worth the trouble for us to troubleshoot this. Another thing that happens somewhat frequently is ending up with weird YAML dependencies, things where like you have duplicate packages installed, you have multiple versions of a package installed, you have packages with circular dependencies or more like octopus-like graph dependency things. These you can mostly fix with package cleanup, given time and patience. We have a wrapper around package cleanup that takes care of most of these things automatically, and it looks at the situation by running YAML and grabbing the output, and it decides, should I roll forward or backwards? And that works. That mostly works. Finally, I mentioned before how the packaging infrastructure works. One thing we did to improve on top of that was add support for BitTorrent in YAML. So we have a plugin called Package Torrent. It's on that pull request if you want to pull it. It's just a standalone plugin. And what this does is, when you YAML install, instead of downloading over HTTP all the files, it asks, can you make me a torrent of these files I need? And the other side serves the torrent, and you get it. This also has the added benefit that if you have a lot of machines trying to install the same stuff at the same time, it's BitTorrent. So you get seeding for free. Now let's talk about dcrpm. dcrpm is a tool we wrote to automate detection and remediation of common RPM issues. This is mostly, at the core, it basically runs db for verify on the database, and then based on what happens there, it decides, should I rebuild the database? Should I do other things? Are the processes stuck with a lock on the database that they will never get back, in which case they probably should be killed? Are there 20,000 YAML processes running on a machine waiting on the same file that will never go away? Things like that. And the nice thing about this is that these are all things that we used to do by hand. Like we used to, oh, this machine looks broken. You go on the machine, look at that, oh, fuck, I need to fix this. And you do fix this by hand. And we had like a long wiki page with like how to fix common problems we find. But like code works a lot better than long wiki pages. This tool dates back to, I think, 2010. The original version was in C++. Last year, a colleague of mine, Sean, rewrote it in Python because he wanted to run it on OS X. In case you're wondering, we have OS X running on a bunch of Mac minis for doing things like continuous build for like the Facebook iOS app and stuff like that. These are Mac minis running OS X, but they run Chef for management because that's what we use for managing things. And they have RPM and YAML installed because that's what we use for package management. And it works. It works as you'd expect, more or less the same way it works on Linux. So this software works on both Linux and OS X. The way we deploy it is that before every Chef run, this runs because Chef works well, what's going on here? Okay, nope. I'm not sure what's happening. Okay. Oh, well, we'll see. Yes, this runs before the Chef run on every machine because Chef works a lot better if I can install packages on the box. You can run it in cron as well. The idea is that you would run this periodically on a machine and it would ensure that things stay healthy. It's on GitHub on that org. It's in active development. We have a few things pending, actually, that we're going to try and get merged in the next coming month. Just to show you, this is before we roll this out and after we roll this out. I can't put X's on graphs because reasons, but you can figure out this is time, this is stuff happening. And before we had this, there was a lot of stuff happening. After, there is less stuff happening. It's worth pointing out, though, there is still a baseline. Like, this doesn't solve all the problems in the world. So there's definitely room for improving things. Work that is coming up in this space that we hope to publish soon is the package cleanup wrapper I mentioned. We're hoping to merge that into dcrpm so we can use it. You can use there. We're going to test. There's a new database format being developed in RPM that we have been working with them to roll out and test so we can provide them feedback on whether that works better. We're going to try and get some numbers on how DNF works in production for our use cases, especially in terms of like, does it work better or worse for these kind of issues, and what can we do to make things better? And finally, we've been working with Chef the company, on in making sure the DNF package provider is at feature parity with the YAML provider. All right, let's talk about operating system upgrades now. So as I said, I've been at Facebook for 6 years. I lived through going from CentOS 5 to CentOS 6, and then from CentOS 6 to CentOS 7. I ran the update from 6 to 7 for the last few years. That's how I got the jacket. And the way we do updates from major releases at Facebook is that we don't do in-place updates. We don't do in-place updates because they're not really supported. And in general, if you nuke a machine and rebuild it from scratch, you're sure where you're starting from. So it's a lot easier to cut out potential problems. And this also has a nice side effect that it gives you a clean slate. If you're going to have to rebuild every single machine in the fleet from scratch, maybe you can use this as an opportunity for getting rid of this old deprecated piece of software that happens to run on all the machines but is not really useful anymore, but 5 teams are still relying on. Maybe you can, in the case of 6 to 7, maybe instead of having 5 different ways for doing server supervision, you can try and get everybody to use systemd instead. And so that's the approach we try to take, given that you're going to have to reprovision the machines, and reprovisioning machines at Facebook is relatively straightforward. I'll have a few words about that at the end. We try to use it as an opportunity for making things better. So what we did for Cent 7 is that it took us about a year to go from initial POC, which was a bunch of engineers getting a machine up and running and booting and almost there, to a production machine. And a production machine means a machine that can run Chef from start to finish, where all of the daemons that we have that run on every machine on the fleet are built, can run, are supervised properly with systemd, where the monitoring stuff works, so you know if the machine is actually working, where you can deploy software. After that, you're mostly done. Like after that, most of the actual engineering work, at least on my side, is mostly there. What happens there is then that everybody else has to migrate their machines, which means they have to rebuild every single machine in the fleet. And it's not just going through the process of reimaging the machines, but it's also validating and making sure that your service works the same before and after. And dealing with stuff like, oh, netcat is different in CentOS 7, and if I'm hard-coding the command line arguments, I need to take care of that. Or, oh, this uses systemd, and I used crazy internal service supervision thing that somebody wrote 5 years ago. I need to port that. What we did for helping people throughout this process is, well, we wrote a lot of documentation. We wrote fairly early, we started writing what we call the porting guide for CentOS 7, where people could go through and see, okay, these are the common things that people hit, this is how they resolve them. We wrote automation tooling, so for simple use cases where I have 100 machines, they mostly do the same, they're stateless, you can just point this thing to them and it will just go and one by one reimage them, and if they're fine, in a week you're done. But then not everybody's stateless. Like if you think a web server is stateless, if you reprovision it from, there's no data to save, it's a web server. Also there's a lot of them. Databases are stateful. If I nuke a database, there is data. Yes, there's replication, but then it needs to be copied back. If I nuke all of the databases at once, that is bad, of course. So these have to be dealt in different ways. Like while you can use one approach for managing stateless services, for stateful services you have to be more careful. We also found out fairly soon that there were interesting dependency issues where, so on CentOS 7 you run systemd. We want to run a modern systemd. A modern systemd requires a modern kernel. So fairly early we said, okay, if you're running CentOS 7, you have to run from this version of the kernel onwards. But some teams hadn't qualified that version yet. And when they went to test it, they were like, there's a performance regression here. And they did not expect that. So that caused some trash in this process, because then people had to deal with something else. I guess the thing here to keep in mind is that there's a lot of externalities and things that you have to consider in advance when going through a process like this. And I think we learned a lot when we did 5 to 6 initially. We learned a lot with 6 to 7. And I'm sure when we'll do 7 to 8, things would go even better. My expectation is also that 6 to 7 was special because systemd was a big change, and because there were a lot of fairly sizable changes in the distribution. I'll be interesting to see what happens when we start working on 8. Now this is for major releases. For minor releases are easier. For minor releases, we have a thing called rolling OS updates. And the way this works is that every 2 weeks, we get the updates that Upstream publishes, and we just roll them out. Because we're not crazy. We're not going to reimage the entire fleet every 2 weeks. And you can opt out of these in case of emergency. There's a big red button to stop this if things go wrong. The implementation is pretty simple. There's literally, that's a path on the server, on the YAML stuff. We just rsync from Upstream in a dated directory. We have automation to do that. We don't do that by hand. And then in Chef, there is logic that goes, should I get the update? Yes, cool, YAML upgrade. And it kicks off a YAML upgrade at the end of the Chef run. Before that, it has a fairly complicated logic to do things like, yes, I know that I need to do the update, but I know you have this package installed, and I know this needs special casing because reasons. And usually we have to write this special casing for a handful of packages for every time we do this. But it's most of the time it's fine. And then we test it. We test it on our own machines. We start canarying it out. We go on small percentages of the fleet. This usually gives a signal on, is it fine, is it not fine, is there by any chance something that came out that is causing problem, and then we roll it out on the fleet. All right, let's talk about Chef. So we use Chef for config management, as I said. I'm not going to talk about Chef in depth here, but what I want to talk about is how we use Chef and how is that different from what you would expect. So the things we want from config management, there's a few core properties that we want. For example, if you're not fluent in Chef, that means keep SSH enabled and started. Now that's idempotent. What that does is it looks, what's the state of SSHD on this machine? Is it running? Cool, we're good to go. Is it not running? Should I start it? Then I start it. It doesn't go and always run etc.d SSHD start or systemctl start SSHD. Now in this case, doing that would also be idempotent. But if you look at the case of like installing packages, that's not quite the same thing. You don't want to like yum reinstall a package on every time you're doing a Chef run. The other thing we do is try to separate apart data and configuration. So in this case, we have cookbooks that know how to do some things like set up the network or manage sysctls. And that's where the knowledge lies. And these are cookbooks my team writes. And then these cookbooks expose APIs that other customers can use. So if I'm running a service and I know that on my service I need this one set up in that way, I can write a block of code and that will take care of it for me. If I have a service and I know I need to override a sysctl to some value, I can do that. Now this is pretty powerful because this means on one side you don't have to know necessarily how to do these things. On the other side, these cookbooks already give you say in default. So, okay, I'm overriding this value, but then after a year I realize I didn't really need to do that. What I do is that I just delete that line, and then it will just revert to the default. I don't have to worry about I'm maintaining my own personal copy of sysctl.conf that's only for the databases, that has only one override, and everything else is copy pasta from the common file. But then they diverge, and I never know what to do there. The other thing we do is that Chef is Ruby. It's a Turing-complete language, so you can do fancy things. Like you can write a method that does a lot of internal logic. Like this is an internal example for setting up some fancy networking thing for doing direct source routing, but direct source return. But the way, it doesn't matter what it actually does, but the point is that you can write fairly complicated logic that is then exposed to the user as just a simple function. We use Chef in a bit of a different way than the community uses Chef. If you look at community cookbooks, they mostly use providers to expose APIs. We do kind of the opposite. We expose APIs using attributes, and we use providers for implementation. The main reason for doing that is that this allows us to do this kind of thing, where we have global defaults, so default values for sysctls that we know work everywhere. And these are on every machine in the fleet. But then I run databases. I know on my database I should have this override for this value. So I set that line in my database-specific config. But then I run databases for this specific product. And on this product, I know I should have another override. But then things change, and I change my mind. So if I'm on that product and I delete the override, I fall back to the database one. And when that goes away, I fall back to the standard default. So everything is always managed. And this manages sysctl.conf as a whole, in the same way where, like, say, our cron cookbook manages cron tab as a whole. So you're always sure of what the state of the system is. The way we use Chef, there's a document on that GitHub repo called philosophy.md, oh, fuck's sake, that details how, this is going to be interesting, details how we, this kind of approach we have to Chef, and how things work. There's also some tooling there. If you're interested in more details, I don't know what's going on here. If you're interested in more details about this, my coworker Phil did a bunch of talks about Chef throughout the years. The last talk he did was at Atmosphere in 2014, and it's linked there, and talks extensively about how we run Chef at Facebook. Yeah, I haven't even touched it. I don't know what's going on. I mean, I can keep talking in the meantime. It's fine. So more details on how we run this infrastructure. We keep our Chef cookbooks in source control in an internal repo. We split cookbooks between core cookbooks that manage core parts of the operating system and give APIs like FB networking, and cookbooks that are, say, setting up this service that only runs on this specific set of things that this team cares about. We have open sourced a good chunk of our core cookbooks. They're on GitHub under Facebook Chef cookbooks. We are trying to get more of those out, and these all use this model and this API that I've described. The way we run Chef on machines is that, well, we run Chef client, of course, but we don't run Chef client directly. We have a small Ruby wrapper that we run that's called chefctl.rb, and what this does is that it takes care of when you run Chef. It makes sure that the output is what you would expect. It takes care of logging, it takes care of locking, so you don't end up with like 5 instances of the client running at the same time. It also has like a plugin mechanics, so you can write custom tooling for it, for doing things like, say, running dcrpm before you do the Chef run. This is on GitHub in Chef utils, in that repo. On the server side, Chef has a client-server model. On the server side, we try to treat our servers as stateless as possible. So we have a thing called grocery delivery, and what it does is that it watches the source control repos, and every 5 minutes it knife uploads all of the codebooks that change to the servers. So if we need to say rebuild a Chef server, it's easy. We just do it, and then grocery delivery would make it up to date shortly after. The way we test Chef, because testing is kind of important, because this runs on every box in the fleet. People do development on their development machines, and then they test on real machines. We want people to test on real machines, because that's the only way you'll know that what they're doing is actually going to work. We have a tool called Taste Tester to do this. It's open source on that org. The short version of what it does is that it hijacks Chef on the target machine and makes it point, instead of pointing to the infrastructure Chef server, it makes it point to a Chef server that's running on your dev machines. And it spins up a local server with Chef 0, points your target, runs Chef, so suddenly the target machine is getting codebooks from you and not from the fleet. And this makes it very easy for people then to figure out and iterate, because they can make a change, oh, Chef is failing, make a change again, upload, and look. And we have code review for all of this stuff, of course, and we always enforce with the code review process that people actually tested their changes. Because again, we don't want people to blow up the fleet. All right, let's a few words about provisioning. Provisioning is how we get machines from 0 to production. We use Kickstart, the standard Kickstart flow that everybody else uses, I guess. We had to do a bunch of things to make this work reliably at scale. We use Kia for DHCP, and we wrote a bunch of hooks to Kia so that they could integrate with our inventory system. We have a DHCP load balancer called DHCP-LB to make this scale better. I believe this one is written in Go. And then we have fb-TFTP, which is our scale-worthy TFTP server. These are on GitHub on those orgs. When we boot from the network, we don't boot into Grub. We boot into something we call LOL, which is just a tiny Linux kernel with BusyBox. This boots, brings up the network, fetches what it needs to fetch to make Anaconda work, and does its things. We did this because when we have to do fixes to say fix driver issues or IPv6 issues, the network stack in Linux is a lot easier to work than the network stack in Grub. Plus, we have a lot of Linux developers, so it makes sense. We run Anaconda. We don't use Anaconda from CentOS, however. We use Anaconda from Rawhide to install CentOS. We've contributed a few changes to Anaconda over the years, and we're working with the team to try and leverage as much as possible from what the community is doing with Anaconda. In terms of orchestration, we have internal tooling for doing things like make that machine rebuild, or what are these machines doing, or show me the state of these jobs. This is all pretty specific to our infrastructure. It's not terribly interesting, so I'm not going to spend much time on it. And before closing, because I know that containers are the hot topic, I wanted to give you a few words about containers. So we have our own container platform as Facebook. It's called Tupperware. It was written many years ago before containers were really a thing. So it has its own implementation of containers that's kind of like LXC, but not really. And over the years, we've been working on this and improving it. And the latest iteration we have that we are working on right now leverages a lot of features that we finally have available. It uses ButterFS, so we can have snapshots and layering. And it has this concept of layered images. So we have a base image that is just CentOS, layered with CentOS plus Facebook-specific stuff, layered with CentOS plus Facebook-specific stuff, plus stuff that I need for this job, or stuff that this team cares about, like, say, packages or configuration. And the way this configuration is defined is by using Chef, specifically Chef Solo. So this makes it very easy for a team to say, OK, I need the base image plus its 5 RPMs, but I already know how to get RPMs because I know how to write Chef. There's a talk that Zoltan and Zil, co-workers of mine, gave at All Systems Go that you can see for more details about this. This is not open source, unfortunately, because it's deeply tied into infrastructure stuff. I think we would like to get it open source at some point, but it's going to be a lot of work. All right, questions? Yes? Yes? The packages, the actual RPMs. Yes, the actual binary RPMs.
So how much time it takes to create one commit? I guess it
Oh, it doesn't take that much. So if you're importing, the question was, we use SVN, what do we store in SVN? And we store the packages, and how long does it take to do a commit? It doesn't take that much to do a commit. If you're importing, say, the entirety of OS, yes, it's going to take a while. But if you're just updating one package, it's pretty quick, like seconds, I say.
And the follow-up question, did you look... Yes, thank you. Did you look into using some kind of repository management software, like Pulp, for example? Or
we've looked at a bunch of things over the years, and I'd be interested in talking with you after this. If you have ideas in this space, I think right now this implementation works, and this is the same implementation we had for a long time. As I mentioned in the talk, we are looking at an alternate implementation that uses Gluster. But yeah, if you have ideas, I'd be happy to hear them.
Well, I was thinking of questions only.
Yeah.
ButterFS only for containers or the whole system? I mean, the root is also on ButterFS.
It's not on ButterFS on every machine yet. We have support for ButterFS root. It works fine. The default on the majority of the fleet for the root disk is still Xed. We're probably going to switch it to ButterFS at some point. ButterFS for root buys you some things, but I don't know if we necessarily want to reimage the entire fleet just to switch to ButterFS root, because you would have to do that. We do use ButterFS for data drives for a lot of things. I couldn't find quickly, but there have been public talks about our use of ButterFS, but I couldn't find quickly a link to put in the slides. But actually not most, all of the work we do for ButterFS is public, and it's in Upstream 3. The other thing we've been doing is using loopback file systems. So even if your root file system is on Next, you can use a loopback for, say, the container stuff that is ButterFS. So you can still leverage the ButterFS features without having to reimage the box. Any other questions? Yes.
So speaking from the perspective of someone who comes from the RHEL world, the idea that you would swap out the kernel systemd and a big element of the package management layer is kind of amazing to me. I'm curious, are there any broad categories of issues you've encountered above that as you do that?
What kind of issues?
Well, you mentioned kernel performance regressions, but so many other packages interact with, say, systemd.
So for systemd specifically, it's been fairly straightforward. The main issue we found is the compat-lib stuff, where there's something like 20 odd packages in CentOS that link directly against libsystemd-daemon or libsystemd-journal, which are no longer provided because Upstream moved to having a libsystemd.so. So we fixed that by just providing the old libraries with symbols that reference to the new one. That was the main thing. There have been the occasional, I think that's actually been the main thing. I can't think of any other major issue that came out from doing the backport. Init scripts has been fairly straightforward as well. RPM has been practically a drop-in replacement. We haven't really seen any significant issues there. My feeling is that you would see a lot more issues on, say, so one example for something we did see is with util Linux. We noticed sometimes with util Linux there are changes between things, like, say, the latest util Linux doesn't ship tailf, for example. They just don't. Like if you don't know, tailf is exactly like tail-f, but it's a standalone command. I don't know why it exists. Nobody was using this, but I noticed this. So what I did was when I shipped this update, I also shipped in chef a one-line shell script called tailf to take care of it. We had an issue, I'm trying to remember the specifics, but we had something to do with util Linux where something changed in the way loopback mounts were managed that caused us issues on the container platform. But I'm blanking out on the details of that, but it wasn't something major. It was like, oh, this is a problem. We found it out during the rollout, we fixed it, and that was it. And it was actually something that had been fixed upstream already in master, but wasn't in a release, so we just cherry-picked the patch from master, threw it in, and it was fine.
So it was a fairly focused set of issues.
Yeah. It's also the other thing to keep in mind is that we don't do this on the fleet entirely at once. Like, we don't go from systemd 233 to 234 on 0 to 100 in a day. We'll start doing it on 5 machines. We'll then slowly ramp it up, and we'll have customers giving us feedback on whether are things okay, are you seeing any issues. We have a set of canaries. We know people that are specifically sensitive to changes like systemd, for example, that will go to them before, hey, we know there's a new thing coming. can you give us a heads up? Like we have the people, for example, that manage, do Android stuff, where they have a lot of Android devices physically connected over USB, and they use systemd services to manage this stuff. And that's an example of something that we try to get input from them through our releases, because maybe, say the way device allow is handled changed a bit or stuff like that. But yeah, no, it's been fairly smooth.
Are you using or are you planning to use video that application?
I'm sorry, I couldn't get that.
Video permabit technology. Right now, it's the red.
I am not familiar with this, I'm afraid. But I would be happy to talk afterwards.
Okay.
Yes.
Something goes wrong during your canary rollout. What happens to those machines? Do you have a mechanism for rolling back, or do you just blow those up?
For single package updates, if something goes wrong in the canary, do we have a way to go back? For single package updates, yes. Generally, you can go back. We have a thing called slow roll internally, which is basically the short version is that it lets you say things like, given this package and given this set of constraints, what version should match to what constraints? So all the dev machines that fit in this 1% shard get this version. All the dev machines that fit in this 5% shard get this other version. And then you change the numbers. For package updates, generally you can go back. There are some exceptions here. We had one case with systemd where the Upstream changed the packaging and split packages around, which was, we still could go back, but going back required some fiddling. For other stuff, like say if a rolling update fails, you can usually recover forward, but we generally consider those irreversible, so you're not going to go back from 7.3 to 7.4 to 7.3. If you really, really had to, you probably, we would advise you to reprovision the machine. There might be ways to go back, but generally it's not worthwhile, because machines are expendable at Facebook. That's the other thing to keep in mind. Like, because we have a lot of machines, they break all the time, just because of the sheer number of them. So you can't really assume that a given machine will always be up and will always be fine. If you're designing your service on this machine must absolutely never fail, it's not a good service.
All right, we have. Okay.
Your transition from YUM to DNF, did you run into very many CLI compatibility issues or have to make a significant amount of change to your scripts or other automation tools to transition?
Oh, so to be clear, we are still using YUM. We haven't transitioned yet to DNF. We have DNF installed in production, and we've done basic validation that it works and it can install packages. The main reason is that it took a while for Chef to get feature parity in the package provider for DNF with the package provider for YUM. I think the last time I checked, it was more or less there, so I think this half will probably start looking at that more in depth. So far from what I've seen, I'm not envisioning major issues from that point of view, because we don't have that many things calling YUM directly. We actually try very, very hard to make sure people don't install packages by hand, and we try to tell them to go through Chef, to the point where, say, on development machines, the advice we give people is, yes, you can YUM install stuff. Everybody has root on their dev machines, so you can YUM install stuff if you want. But what we suggest you to do is that you set up an override in Chef, so that later, if your dev machine dies and you get a new one, you still get the packages you like and the configs you like.
That's it, yeah.
All
we
right.
don't have any time for questions, so
Thank you very much. Well,
I'm glad we sorted out that projector thing.
yeah, I'm not sure what was happening. I wonder, because there's a cable under here. I was almost wondering if I was tapping on it and doing something there. Yeah, I don't know. But no, it's fine. It worked out. So thanks for the help. No problem. It's much appreciated. I guess this was